mix with, how much of the 12% sufficient, 20, that actually makes sense, because 15% is halfway between 12% and 18%, so it makes sense that you'd have equal amounts of the mixture, right? 20 and 20 milliliters of 12%, 18%, to get a solution halfway between. So I made up a good example off the top of my head that didn't have tricky decimals in it. All right, so also in chapter 1, let me see if there's anything else I want to do in chapter 1. I think that's it. You probably need to go, right? Catch the bus?
10 minutes.
10, oh, okay. Oh, yeah, because it comes at like 20 after,
Mhm.
right? Okay, good. All right, so let's go to chapter 2. Those are kind of the main ideas of what you can expect to see in the final. So let's go, but always look at your old tests and everything, right? So let's go to chapter 2 where we were working with functions. And we had functions in different formats as points or equations. So let's start with functions as points. And we had function operations and inverse functions. So for example, suppose we have, so this is chapter 2. Write that a little here. Chapter 2. Okay, so we're on number 3, right? Okay. So suppose we have f of x equals the following points. 4, 0. 2, negative 3, and 5, 1. G of x equals the points 2, 4, 4, 5, and 0, 3. So we're going to do some function operations. A, find G divided by F, state its domain. So if we're doing the function operations of addition, subtraction, multiplication, and division, those are only valid for the intersections of the domain, where the domains intersect. So we should start with the domain. And we know sometimes with division, math teachers are tricky and we give you something that you have to throw out of the domain because it causes you to divide by 0, right? But let's start with the domain because math teachers are tricky anyway, right? So for the domain, what elements of the domain do they both have in common?
4, 0, 4.
They both have 4 as x, right, elements. They both have 2. Do they both have 5 in the domain?
No.
Do they both have 0 in the domain? No. So these are the domain elements, but again, maybe we won't be able to use both of these. So they both have domain x values of 4, and they both have domain x values of 2. So what we can do, or at least try to do, of g divided by f, is g of 4 divided by f of 4. And then we can try to do g of 2 divided by f of 2. It doesn't really matter the order here that we list our domain, and then we do these operations, okay? So going to the g function, what is g of 4?
0.
In the g function, g of 4 is 5. So when x is 4 in the g function, y is 5. In the f function, what is f of 4?
0.
0. When x is 4, y is 0. Are we allowed to do 5 divided by 0? No, there you go. There's that tricky math teacher thing, right? So that is undefined, so we need to go back and throw 4 out of the domain. Remove 4 from the domain because we cannot do g of 4 divided by f of 4. That makes undefined dividing by 0. Okay. So let's try g of 2 divided by f of 2. So g of 2 is 4 in the g function when x is 2, y is 4. And f of 2 is negative 3. In the f function, when x is 2, y is negative 3, and there's my answer. You can write it as negative 1 1/3, negative 1.3. And so remember, if you were doing this in MyLabs Plus, they would make you write your answer as a point. So in MyLabs Plus, this is fine for me, but in MyLabs Plus, starting with a domain of 2, as a result of the quotient function, you're going to get negative 4/3, which is just another way to write your answer for MyLabs Plus. Which reminds me, on MyLabs Plus, there is a that's pretty thorough, that you could do to practice. It's made as a homework, so it has lots of help buttons, and it doesn't affect the grade at all. It's not connected to the grade book at all. So that's another good way to study for the finals, to do the review on MyLabs Plus for the final. All right, so let's go to question B. Find F after G. Sometimes it says of X, or it just says F after G. So this is F after G. And so it's best to nest these and call this F of G of X. F of G of X. So the way we can do this is we go to G of X, and if we have a range item of G of X and it's in the domain of F of X, we can do this operation, this composition function. So let's start with G of X. G of 2 gives me what? 4. Is there an F of 4?
Yes.
Yes, so we can do that. We can do F of G of 2. We can do that one. So let's go through all of them and see which ones we can do. G of 4 gives me what? 5. Is there an F of 5?
Yes.
Yes, so we can do that one too. So we can do F of G of 4. Again, better to nest them. So finishing with G. G of 0 is 3. Is there an F of 3? No, because we do not have the range of G3 in the domain of F, X. So we can't do that one. So we can do these two though. So let's go through this process. So again, G of 2 is what? 4. So G of 2 is 4. Now we do F of 4, which gives me 0. So my answer is 0. Going to the G function, G of 4 gives me 5. So let's write 5. And F of 5 gives me 1 as our result. So for me, it's fine to write your answers like this. If you were doing this in MyLabs Plus, they would want your answers as points. So what they would say is for the domain of 2, after the composition, we get 0. For the domain of 4, after the composition, we get 1. If you were doing that for MyLabs Plus, it would want your answers as points. Starting with points, MyLabs Plus likes answers as points. Okay, so one more question. Question C. Is F of X invertible? If so, find F inverse of X. If not, why not? So is F of X an invertible function? Invertible means it has an inverse. What has to be true for a function to have an inverse? It has to be a what kind of function? 1-to-1, right. And so that means it's a function. Each x has only one y, but it also means, and it passes the vertical line test, it also means that each y is paired with only one x. It passes the horizontal line test. So going back to F, is it a 1-to-1 function? Does each x paired with only one y?
Yes.
Yeah, so it would be a function, but is each y paired with only one x? So 0 is only paired with 4, -3 is only paired with 2, and 1 is only paired with 5. So each y has only one x, it's a 1-to-1 function, so is it invertible?
Yes.
Yes. So now we can find the inverse function, and how do we do that? This is the easiest question on the test. Switch x and y's, right? And so the inverse function would be 0, 4, what's the next point?
-3, 2.
-3, 2, and the next point would be?
1, 5.
1, 5. Now, if you had y values paired with more than one x value, then it would not be 1-to-1 and it would not have an inverse, because then it wouldn't pass the horizontal line test. So just going forward with that, if I had same question but we were looking at the graph, is it 1-to-1? Or similar question, I should say, not same question, similar question. Similar question, is it a 1-to-1 function? Why or why not?
No.
Well, let me give you the graph, you don't know yet. Let me give you a picture. Okay, so suppose we have, again, this would be a graph. Suppose suppose we have a good old parabola. We know that's a function, it passes the vertical line test. Is it a one-to-one function?
No.
No. Why is it not a one-to-one function?
Doesn't pass horizontal.
It doesn't pass the horizontal line test, right? So, not one-to-one. Fails the horizontal line test. And the horizontal line test says, if you can draw the horizontal line that intersects more than one point, like it does here, then it's not one-to-one. Because then you've got y values paired with more than one x value, right? And if we were to list those y's, they would have two different x's, so it's not a one-to-one function.